All right, again, last section in the chapter, 3-4, is solving exponential and log equations. So we start with the exponential ones. Obviously, if your equation starts with something that has an exponent on either side of the equal sign, that's an exponential equation. There are two different kinds. One is if you can change the base to be the same. So we did these already. Like if I had 2 to the x equals 8, I would change it so that it's 2 to the x equals 2 to the third. And then I would set my exponents equal to each other, and I'd get x equals 3. So that's what it means by with the same base. Can you change them so they have the same base? If you do, you're going to do that, and then you're going to ignore the base and set the exponents equal to each other. That's the one-to-one property. The second happens if you cannot change the base to be the same. So if I had something like 2 to the x equals 3, for example, there is no way to rewrite 3 as 2 to the power of something. So for these, we turn ln into a verb. We are going to ln both sides of these equations. The exponent on the 2x gets bumped to the front. It would be x times ln of 2 equals ln of 3. And then we would divide both sides of the equation by ln of 2. And this is where your calculator comes into play. If I didn't have a calculator, I would leave it as ln of 3 over ln of 2. With a calculator, I'm going to do ln of 3, close my parentheses, divided by ln of 2. And I get 1.5849. So 1.585 if you're rounding to 3 decimal places. So again, if you can change the base to be the same, you're going to do that, and then use the one-to-one property, right, not yours. Use the one-to-one property to solve it. If you cannot, then you ln both sides of the equation, and then use your rules about expansion to move things around. All right, so look at 1. Can we change 64 and 32 to be a power of the same base? Yes. What would be the base? What's the common base there? 2. 64 is what? 2 to what power? 2 to the 6th raised to the 3x. 32 is 2 to the 5th raised to the 2 plus x. And then let's say, again, like you don't know that. I'm going to take 64, break it down. So 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. And then count them. 1, 2, 3, 4, 5, 6 2s. Okay. And for 32, it would be 1 less than that. So 5 2s. Now what happens when you raise a power to a power? You're going to multiply. So I'm going to multiply 6 times 3x and 5 times 2 plus x. I get 18x equals, distribute here, 10 plus 2x. And then I want to solve for x. It's 2 to the 5th. Which one are you saying? Oh, here. Yeah. This should be 5x. Thank you. And then we're going to subtract the 5x. 13x equals 10. Divide both sides by 13. And x equals 10 over 13. And notice I didn't use a calculator that time. My answer would be kept exact. That would be on the portion of your test that does not have a calculator. Questions on that one? All right, go to B. Can you change these so they both have the same base? Yeah, what would it be? 5, so the left side stays, and 1 over 125 is 5 to what power? Negative 3, good. Now grab your exponents. 2x equals negative 3, divide both sides by 2, and x equals negative 3 halves. Still good? All right, go to C. Yeah, sure. First of all, this is the first time I've had something in addition to an exponent or an exponential term on one side of the equation. I want to isolate it. I want to get whatever's raised to the power by itself. So I'm going to start by adding the 9 to the other side. And I get e to the x equals 28. Is there any way to change them so they have the same base? No, so we are going to ln both sides of this equation. What is ln of e to the x? Just x. Good. The ln of e cancels to give you its exponent. So this is just x. Without a calculator, I'd be done. That would be my answer. With a calculator, I'm going to actually find the ln of 28. And it's 3.332. What'd you get? Good. ln of 4, or 1.386. We'd ln both sides. Ln of e cancels just to give you the x. And x would equal ln of 4, or 1.386.
Where's the ln?
On here, there.
Oh.
Yep. Good so far? Yes? Okay. Then we just get to the point in which, like, something for A, you got to do a little bit more work, and then we'll pause. We'll talk about B before we get there. But notice the instructions now say solve the equation algebraically. That just means solve it, okay, without a graphing calculator. And then round to 3 decimal places. So what's the first thing you would do for A? Subtract the 7. I got to isolate that e to the x eventually. So I'm going to do -2. E to the x equals -2. Then... Good. Divide both sides by -2, and I get e to the x equals 1. Do you know this answer?
0.
It's 0. Good. Without even having to do the work, anything that results in 1 from exponential has to be 0, so I can go straight there. I could have also ln both sides, and ln of e to the x becomes just x, and if you literally type ln of 1 in your calculator, you will also get 0. All right, B looks weird, okay? And it is basically just a factoring question disguised with ease. So if I had, you could do substitution. If I wanted to substitute this term as A, I would not recommend this, but this is the long way around it. I could say e to the x equals A. So then e to the 2x would be a squared minus a minus 12. Then I could factor it. These would both be a's. The factors of negative 12 that sum to -1 are what? Good. And then I can set them each equal to 0. And I would get a equals 4 and a equals -3. But I'm not solving for a, right? We're solving for x, so I have to plug the e back in. So 4 equals e to the x, and e to the x equals -3. And then I'm going to ln both sides of the equation. And I get x equals ln of 4, which we just did like a minute ago. It is 1.386. And I get ln of -3. What happens when you try to do that in the calculator? It's error. You can never have the result of something that has a base become a negative number, right? E could never become a negative number by raising it to a base. You will never be able to log or ln a negative number or 0. So I ignore this answer and I keep just this one. Now that, again, like I said, that's kind of the long way around doing it. If you recognize from the beginning that this can be solved using graphing, you don't have to do the a squared. You could literally come over here and say this would be e to the x and e to the x instead of a, or instead of an x in that first term, because e to the x times e to the x is e to the 2x. And then just look for the factors of -12 that sum to -1, which were -4 and +3, and then split and solve from here. And you're at this step. So as long as you recognize that that is really factoring, so if I have e to the 2x and e to the x, it's really just a factoring question. You can break it down, except instead of having an x in that first spot, you have an e to the x. Questions so far? All right, those are the exponential ones. Now we get into log. We will know the difference because the question would literally say log or ln, okay? So if you have a log or ln somewhere in your equation, there's several different kinds of way to approach it depending on what it looks like. The first of these says if there's only one log. So if there's only one log, like log 2 of x equals 3, for example, only one log there, I'm going to convert this into exponential. 2 to the third would equal x, and x would equal 8, something like that. The second kind is if there's only one ln. So if this now said ln of x equals 3, I'm going to convert that ln to log base e of x and then convert it to exponential. And I'd get e to the third, which is 20.086. So 1 ln or 1 log, we convert to exponential. The third kind is if there's 1 log or ln, I should say, on either side of the equal sign. And for these, we use the one-to-one property. We literally ignore the log. We drop it off, because if it's on both sides, it's okay. And we set what's left equal to each other. So if I had log x plus 3 equals log 7, as long as the log base on either side is the same, so it could have been log base 3, log base 10, log base 5. This is log base 10. If there's one log on either side of the equal sign, we ignore the logs, and we set what's left equal and solve it. Same would go if it's ln. If it's at ln of x plus 3 equals ln of 7, I would ignore the ln's, and I get the same answer. That's using the one-to-one property. Sure. And the last is if there are multiple logs on either side of the equal sign or on both sides of the equal sign. Your goal is to condense using your log property. If it's addition, when you condense, it becomes multiplication. If it's subtraction, when you condense, it becomes division. And then if what remains is 1 log, we convert to exponential. If what remains is 1 log on either side of the equal sign, we use the one-to-one property and solve it. So that would be something like log of x plus log of 3 equals log of 7. I would condense this side down to be log of 3x equals log of 7. 1 log on either side of the equal sign cancels out, and I get 3x equals 7 and x equals 7/3. Let's say there was only one side of this and not a log on the other side. I would still condense the left side. And now from here, I only have 1 log, so I convert this to exponential. So my base would be 10. I would get 10 to the 7th power equals 3x, and then I would take my 10 to the 7th power, which is obviously huge, and divide by 3. That's 3,333,333. We don't need to go all the way out, but that's how you would do it. Questions? Here is the most important thing on this slide, and that is if your initial equation starts with a log in it, or an ln, because ln is a log, then you have to check your answers. You have to see if when you plug it back in, you would end up finding log or ln of a negative or 0. If that happens, you ignore that root. It's an extraneous root, and you keep either whatever is left, or you would say no solution. So for example, if when I solved this question, I ended up with a negative 7/3. I would check by saying if I plug this back into this x, Is it log of a negative or log of 0? If it is, I ignore it. So if it's a negative 7/3, I would literally cross it through and say that's no solution. If it was 0, I would have said no solution. All right, let's work through some of these. So example 5 says solve the log equation algebraically, approximate the result to 3 decimal places. So look at A. What are you going to do first? Good. Give log the base of 10. And then there's only one log here, so what do I do?
5x equals 10. Is this R2?
Good. 10 picks up the 2. Equals 5x. 100 equals 5x. And x would equal 20. Now there's a log in my original equation, so I'm going to come up here. I'm going to say if I plug 20 back in, is this product 0 or negative? It is not. So I keep that answer. If I want to keep going, I could literally go all the way through and check your answer. But you don't have to go all the way through. You do have to check to make sure it wouldn't be the log of negative or log of 0. All right, what's step 1 for B? Subtract the 5. I got to isolate this ln. So 2 ln of x would equal 9. Then what? Divide by 2. Now the ln is by itself. I can change ln to be what? Log base e of x equals 9/2. And then convert to exponential. X is going to equal e to the 9/2. Which is 90.017. And again, there's a log in the beginning, so I check it by saying if I plug that back into the variable, is what's next to that log or ln 0 or negative? It is not, so I keep that answer. Still with me? Yes?
Wait,
Yeah.
how did you check it?
You just have to check. You're not checking it like technically all the way through. If you wanted to, you could actually plug it back in and let the calculator do that work. See if the left side equals 14. But the goal is if you start with log or ln, which all of these have, you have to plug it back into what's next to it. This time it's just an x. But if it was like an x minus 10, I'd have to actually say, does 90 minus 10 stay positive? If it does, I keep it. If it's not, I don't. If that answer was, let's say that answer was negative 2x next to the ln, and when I plug in 90 and I multiply by 2, it makes it negative, I would rule it out. So it's not just by saying what x is, it's by saying what happens when I would plug it back in next to the log. It can't be 0 and it can't be negative.
Can you condense it to have it as x squared so you can just have
Sure. Yes. Once you move the other stuff you're saying?
Yeah.
Once you move the 5, the question is, can I just bump the 2 there? Absolutely. And it would have been x squared, and then it would have been ln of e to the x squared equals 9, right? And then it would have been it would have been x squared equals, no, wait. It would have been ln of x squared equals 9, log base e of x squared equals 9, and then e to the 9th equals x squared. You'd have to square root it. Square root is the same thing as a half as your exponent. So that's how it gets there. But if you did it like without the, like if you did it step by step in the calculator and you found e to the 9th and then square rooted it, you'd get the same answer. Yeah. All right, last slide. Look at A. How many logs are there? 1. It's only on one side. So we do what? Make it log base log base e, and then we're going to convert this to exponential. So e comes over and picks up the negative 3. Can you raise something to a negative power? No. Yes, you can. Sure you can. You can't make an answer be a negative from an exponential, but you can raise it. It just makes it a fraction, right? This would be e to the 1 over e to the 3rd. So second, e to the negative 3, and I get 0.497. Oh, no, 0.0497. This one bumps this one, which bumps this one, and I get 0.5. And I check it because it has a log. Can I find ln of 0.05? Sure. It can't be 0, but it can be a little bit bigger than it, even if it's teeny tiny. Questions on that one? Okay, now look at B. I've got more than one log on one side of the equal sign, so what do I have to do to it first? Condense it. This is addition, which means what when you condense? Multiplication. So it's log base 3 of x times x minus 2 equals log base 3 of x plus 4. Now, if I only had one log on one side, I'd convert this to exponential. But I don't. I have 2 logs, which means I use the one-to-one property. I ignore these, and I get x. I'm going to distribute this out. Squared minus 2x equals x plus 4. Now what? I got to get everything to one side. As soon as you see an x and an x squared, I'm going to move it to one side because I'm going to try to factor it. Minus x and minus 4. X squared minus 3x minus 4 equals 0. Are there factors of negative 4 that sum to negative 3? Negative 4, positive 1. Split and solve, and I get x equals 4 and x equals negative 1. With me so far? Now I gotta do what? I gotta check. So I gotta check 4 in all 3 spots. 4 here is okay. 4 here, 4 minus 2 would be 2. That's still okay. 4 plus 4, that's 8. That's okay. Then I got to check negative 1. Negative 1 here does not work. I don't even have to keep checking. I'd cross it out. Let's say it did work there. I'd then go here and say negative 1 minus 2 is still negative 3. I can't find log of negative 3, so it would not work there. It would work at the end, but if it doesn't work in any of those 3 spots, you rule it out. And my only answer would be x equals 4.
So you just can't find logs of negative numbers?
Or 0.
Or 0.
Yep.
So if it was negative 1 plus 1, like you'd have to cancel it out as well?
Correct. Yep. Good? Okay, so that's it for chapter 3. The biggest thing I would say on logs is don't get confident because they change. Like, don't be like, I'm going to do a couple and be good. There are so many different variations. You really need to make sure you go through all of them, okay? The homework tonight is obviously on WebAssign. I will, like, if you as a junior, as a sophomore, if you need an extension, I will give it to you, but I would say don't take it. Like, get it over with, do it tonight so that you can focus on PSAT tomorrow and not have 2 things over the weekend. Your goal should be to do this tonight. If you are a junior or a senior or a freshman, I will see you tomorrow. And we will do the review, and then you'll get the review over the weekend. Again, if you're a sophomore and I don't see you tomorrow, my advice would be to just make sure you do the review over the weekend too. And I'll post whatever video we work through together. We'll do the warm-up and we'll do the review.